Alright, so far we've been talking about multiplying binomials, which means we've been multiplying x plus 3 times x plus 4. And we've been doing a lot of work with that. Now there's going to be a little trick for some of the special ones. So we're going to talk about special products of polynomials. Remember, special just means unique, products is multiplication, and polynomials is more than one term. So go ahead and write your title. Let's look at the first pattern. We have the sum and difference pattern. So sum just means addition and difference means subtraction. If you have two binomials that are being multiplied and they have the same numbers here and then they have the same numbers here but they just have different signs, it's going to work out to be a squared minus b squared. Let me give you an example. So let's say we had x plus 2 and x minus 2. If I were to do the FOIL on this, I'll just do that for you. It's going to be x squared plus 2x minus 2x and minus 4. Well, look what happens to the terms in the center. They're going to cancel out. So you just have x squared minus 4. So your answer would be x squared minus 4. Let's look at how it applies to the pattern. So in this case, if you look at your A, right here, your A was x. Your B was 2. Once again, A is x and B is 2. The only difference between these two things is you have addition and subtraction. So if you have the same things here, but just addition and subtraction, those middle terms cancel out. You don't even have to do the math. All you do is you go, okay, I know it's going to be x squared, and I know I'm going to square this one and get 4, and I know it's minus according to the pattern. Let's try another one. We'll do, let's see, how about this one? 3x plus 2 and 3x minus 2. So if we apply the pattern, because we know 3x and 3x, 2 and 2. So all we do is we square whatever's here. So we have 9x squared. I did 3x times 3x. And we square whatever's here, 4, and then according to the pattern, it's subtraction. There's your answer. You don't have to do the FOIL if you can see that pattern. Now let's look at the square of a binomial pattern. So what that means is you have a square here. We dealt with this yesterday. Some people had some questions with it. So this is the second example. You're going to put parentheses a plus b, parentheses closed, squared, and it's going to equal a squared plus 2 times ab plus b squared. So let me show you an example. So let's say we have 2x plus 1 squared. What that really means is 2x plus 1 times 2x plus 1. And then I do FOIL and I go through all this. So I'd get 4x squared plus 2x, that's 4x, and then plus 1. Okay, let's see if it applies to the pattern. So in this instance, a equals 2x and b equals 1, right? So let's just put it into this and see if it matches what we got here. So a squared, so I know a is 2x, so I'm going to square it. So I get 4x squared. And now I'm going to do 2 times my a and b. So I do 2 times 2x is 4x, times 1 is 4x. And then I take my b term, which is 1, and square it. Does it match? It does. And since it's addition and addition right here, you know all your signs will be plus. So all you're doing is squaring your first term, multiplying these two terms together, the 2 and the 1, and then multiplying them by 2 to get the middle term, and then squaring your last term. So you don't have to do the whole FOIL pattern. Here's one with subtraction, and the only difference here is you have a minus sign right here. Okay, so a minus b, the whole thing squared, equals a squared minus 2ab plus b squared. So let me find an example. Let's do 4x minus 1 squared. So we'll apply it to our pattern. So we're going to take our a value and square it. So 4x times 4x is 16x squared. We're going to put a subtraction sign, then we're going to multiply 2 times our a and our b. So 2 times 4x is 8x, times 1 is 8x. So I put an 8x here. And then this last term, I'm going to square, so plus 1. So you don't have to do the FOIL pattern for these, you just use the pattern here to find it out. We will work a lot more with these tomorrow. All right, have a good night.